In this video, we are going to be adding and subtracting rational expressions with unlike denominators. So here are our steps for adding and subtracting fractions, rational expressions, with different denominators. Number one, find the LCD. So when you're looking for the LCD, also keep in mind that you want to make sure that the polynomial in the denominator is always factored, because that's going to make a difference in your LCD. Number two, multiply each fraction, the numerator and the denominator, by what it's missing from the LCD. Number three, combine numerators while writing over the common denominator. And the last step would be to simplify if possible. And remember, the simplifying here is factor and then cancel. So let's recall what it was like when we were just adding fractions that had different denominators, that weren't these fancy fractions. So we have the problem 3/4 plus 1/6. Because they have different denominators, we have to first find the LCD. So remember, we're used to finding the LCD when we were working with fractions and we had to clear the denominators. So if I have a 4 and a 6 and I want them to have the same denominator, I'd start with the biggest denominator of 6. And 4 can't be divided by 6, so that means that 4 isn't a factor of 6. So I'll go with the next multiple of 6, which is 12. And 12 can be divided by 4, so that means that my LCD is going to be 12. So I'm going to build fractions, equivalent fractions, that have denominators of 12, because that is the LCD. So what is missing from the 4? What would I have to multiply 4 by to get to be 12? Well, I'd have to multiply it by 3. So fraction rules say whatever you multiply the denominator by, you have to multiply the numerator by. So essentially, I'm multiplying this fraction by 3 over 3. And I can do that because 3 over 3 is the same thing as 1 mathematically. So now I'm going to multiply the numerators. 3 times 3 is 9, and of course then the denominator, 4 times 3 is 12. I'm going to do the same thing to the next fraction. Well, what I have to multiply a 6 by, or what's missing from 6 to make it a 12? Well, that would be a 2. So I'm going to multiply the numerator and the denominator by 2. So 1 times 2 is 2, and then of course 6 times 2 is 12. Now that I have these common denominators, I'm going to keep that common denominator, which is 12, and I'm going to combine the numerators. 9 plus 2 is 11. 11 is a prime number, so this fraction can't be simplified. So we're going to follow these same exact steps when we're working with the fancy fractions. So example number 2, it's 5 over x minus 3 over x squared. So first step is to find that LCD. So just like before, when you had a monomial and you had different exponents, always go with the highest power. So here I have an x and an x squared, so the highest power is x squared. So my LCD is going to be x squared. So I'm going to build fractions that have denominators of x squared. All right, now I'm going to multiply each fraction by what it's missing from the LCD. So my first fraction is 5 over x. It has one x, but it really means it's missing a second x. So that means I'm going to multiply the numerator and the denominator both by x to get that x squared in the denominator. So 5 times x is 5x. Then I go to the second fraction. Well, the second fraction has a denominator of x squared, so it already has what it needs, so it doesn't need to change. I'm going to just leave it as minus 3 over x squared. Now that I have my common denominators, I'm going to combine the numerators over that. So I've got x squared as the common denominator, and I'm going to combine 5x minus 3 is just 5x minus 3. So now I look to see if I can simplify. 5x minus 3 can't be factored, so this is my simplified answer. 5x minus 3 over x squared. Example number 3. We have 2 over x plus 5x over x minus 6. Now remember, like before when we were solving those rational equations, this x minus 6 is a unit. So my LCD is going to need an x from the monomial x, and it's going to need an x minus 6 from the other denominator. So that is my LCD, an x and then an x minus 6. So I'm going to build those common denominators. And to do that, I need to find out what each fraction is missing from the LCD. So the first fraction, originally the denominator is x, so it's missing the x minus 6. So that means I'm going to multiply the numerator and the denominator by x minus 6. So you can see I've got my denominator already done. Now to multiply the numerator by x minus 6, I need to distribute. So that becomes 2 times x is 2x, 2 times negative 6 is negative 12. And in the second fraction, what I'm missing is the single x. So I'm going to multiply the numerator and the denominator by the single x. So now I have 5x times x is 5x squared. All right, now that I have that common denominator, I'm going to keep it, x times x minus 6, and then I'm going to combine like terms in my numerator. Notice that a 2x minus 12 plus 5x squared, they're all different terms. So I'm going to write these in descending order. So 5x squared goes first, then the positive 2x, then the minus 12. All right, and now I need to see if I can factor this so that to know if I can simplify it or not. So I'm going to go off to the side to see if I can do split b. So a times c, 5 times negative 12, is negative 60. And I'm looking for factors of negative 60 that give me a positive 2. So my factors would be 1 and 60, 2 and 30, 3 and 20, 4 and 15, 6 and 10. None of those give me a positive 2 as a difference. So that's good news. That means that is my final answer. 5x squared plus 2x minus 12 over x times x minus 6. Number 4, we have 3 over x minus 2 minus 4 over x plus 3. Remember that these are units on the bottom, so I always think it helps to write them in parentheses. All right, so let's find that LCD first. So for my LCD, it looks like I have to have an x minus 2 because the first fraction has an x minus 2. And then I need to have an x plus 3 because the second fraction has an x plus 3. So my LCD will be both binomial. So I need an x minus 2 times x plus 3. And then for the first fraction, an x minus 2 times x plus 3. All right, so now I'm going to look to see what each fraction is missing. The first fraction has a denominator of x minus 2, so it's missing the x plus 3. So I'm going to multiply the denominator and the numerator by x plus 3. So when I multiply the numerator by x plus 3, I need to use the distributive power. So 3 times x is 3x, and 3 times 3 is 9. And then in the second fraction, it's missing the x minus 2. I have to multiply numerator and denominator by x minus 2. Now be careful here because what I'm distributing is that negative 4. So make sure you grab that sign. So negative 4 times x is negative 4x. Whoops, sorry, I don't need that extra negative there. Sorry, I apologize. I need to, I'm distributing the negative, so when I combine them, a little tricky, it should be a positive. So negative 4 times x is the negative 4x. And then negative 4 times negative 2 is positive 8. So I want to make sure that I'm combining these, and I've already distributed the sign, so I don't need to have that negative in the middle. All right, now what I'm going to do is combine like terms over that common denominator. So the common denominator is the x minus 2 times x plus 3. And then let's see, we can combine a 3x and a minus 4x. That gives us negative x. And 9 plus 8 is 17. So we end up with negative x plus 17, which can't be factored, over x minus 2 times x plus 3. Okay, next one. Number 5, we have x over x plus 5 minus 4 over 4x plus 20. Now this is a situation where you may not realize it, but the denominator of the second fraction can be factored. So I want to make sure that my fractions are always factored. So always be on the lookout. And when you look at the 4x plus 20, this really has a common factor of 4. So this fraction can really be written as minus 4 over, and when I pull out the GCF of 4x plus the GCF of 4, that leaves me with x plus 5. So I'm going to rewrite this fraction as minus and then 4 over 4 times x plus 5. And then, of course, we didn't do anything to the second fraction. All right, so now let's find that LCD. Well, my LCD needs to have an x plus 5 because I have one of those units. And then the second fraction has the x plus 5 as well, so I don't need to repeat it, but it has an additional 4. So my LCD will be 4 times x plus 5. And this time, I'm not going to write that minus in between because it messed me up last time. Okay, so when I look at the first fraction, what is it missing? Well, it's missing the 4. So I'm going to multiply the numerator and the denominator by 4. So the denominator we've already taken care of, but x times 4 is 4x. And then in the second fraction, notice that it's not missing anything. It already has the denominator. So I'm just going to write a minus 4. Now I'm going to combine like terms in the numerator. 4x minus 4 over 4 times x plus 5. Now I want to see if I can simplify it. So when I look at that numerator, 4x minus 5, once again, I see that I have a GCF. I'll do it right in here. I've got a little bit of space I can take care of or use. So I've got 4x minus 4, and it shares a common factor of 4. So I'm going to pull out the 4, and that leaves me with x minus 1. So now I can write the fraction as 4 times x minus 1 over 4 times x plus 5. And guess what happens here? The 4's are common factors, so my simplified fraction is x minus 1 over x plus 5. All right, we have one more left. I know you're ready to be done with rational expression notes. All right, this one is, oh, I'm sorry, we have two more left. This is number 6. X plus 3 times x plus over x plus 1 plus x plus 2 over x minus 4. So nothing needs to be factored in our denominators, but our LCD needs to have an x plus 1, and our LCD needs to have an x minus 4. All right, so now I'm going to build those those equivalent fractions with the common denominator. So x minus 4 times x plus 1 and this time I can put the plus sign. Plus signs in the middle don't ever mess you up. All right, so what is missing from the first fraction? It has the x plus 1. It needs the x minus 4. Now keep in mind in the unit, the numerator has a unit. So I need to wrap it in parentheses because I'm going to be multiplying it by x minus 4 because that's what it's missing. So you know what that means? It means I need to do some multiplication here. X times x is x squared. X times negative 4 is negative 4x. 3 times x is 3x. And then 3 times negative 4 is negative 12. So I'm going to put the simplified version in my numerator. So that leaves me with x squared minus x minus 12. All right, now let's look at the second fraction. The second fraction has a denominator of x plus 1, x minus 4, so it's missing the x plus 1. So once again, I'm going to wrap the numerator in parentheses so I remember it's a unit. So I've got x plus 1. All right, now once again, I need to multiply the binomial times the binomial. So x times x is x squared. X times 1 is x. 2 times x is 2x. And 2 times 1 is 2. And when I combine like terms in the middle, I end up with x squared plus 3x plus 2. All right, so now I have fractions that have a common denominator. So I'm ready to add them, which means I'm going to keep my common denominator and just combine my numerators, combining like terms. So I have an x squared and an x squared. So 1 plus 1 is 2x squared. Then I have a minus x and a plus 3x. That leaves me with positive 2x. And then we have minus 12 and a plus 2, so that's a minus 10. Right, remember we always want things reduced, so I'm going to go off to the side and just see how I can factor my numerator. So I have 2x squared plus 2x minus 10. Well, first of all, I notice that they share a common factor of 2. So I'm going to pull that out, and that leaves me with x squared plus x minus 5. Oh, and then I look to see, well, are there factors of negative 5 that give me 1? No, there's not. So that's the good news. You can leave it like this since you know it can't be reduced any, or you could write it as 2 times x squared plus x minus 5 over x minus 4 times x plus 1. But notice I look to see if I could reduce it because that's what we do with fractions. We always want them in lowest forms. And because there was no factors of negative 5 that give me positive 1, I knew I could stop. All right, now we're ready for our very last one. All right, this one is 7 over x squared minus 2x minus 15 minus 4 over x plus 3. So just for time's sake, I'm going to tell you that if you do split B, this factors into an x plus 3 times x minus 5. So I'm going to rewrite the fraction as 7 over x plus 3 times x minus 5 minus 4 over x plus 3. So when you think about your LCD, we have to have an x plus 3 and an x minus 5 because that's what the first fraction has. The second fraction has the x plus 3, but it needs the x minus 5. So my LCD is just going to be x plus 3 times x minus 5. So I'm going to make those common denominators first. Right, and when I look at the first fraction, what is it missing from the LCD? It's not missing anything, so the numerator is just going to stay at 7. Well, then I look at the second fraction, what is it missing? It's missing the x minus 5. All right, so now I'm going to multiply out the numerator. I'm going to drag this sign, -4, to both terms. And when I do that, I need to remember that this, now that I use the negative, I can put a plus here. So now it's going to be -4 times x, which is -4x. -4 times -5 is positive 20. So now when you combine those numerators, there's nothing to combine with the -4x, and 7 plus 20 is 27. All over the common denominator of x plus 3 times x minus 5. So yes, these can be very challenging because now our LCD that we've been using for several weeks has a new job. It's not trying to clear the denominators like it was when you're solving an equation. It's trying to help you build equivalent fractions with the same denominator. So take your time on these, go back to the notes, and always ask questions.